Welcome everybody. This is going to be a lesson on sequences and series. This is 14.3 in the book, sorry. Some of you may have seen a little bit about sequences and series, but just in case I'll try to get as detailed as I can. We'll start with what a sequence looks like. Okay, a sequence is essentially just exactly what it sounds like. It's a sequence of numbers. For example, 5, 9, 13, etc. Okay? Symbolically, we call a sequence, when we list them in order, we call the first term a sub 1, second term a sub 2, and so on. Okay? A series is the sum of all the numbers in the sequence. So if I wanted to take the sequence of numbers 5, 9, 13, and I think you know the pattern, the next number would be 17, and make it a series, I would simply add all the numbers up. So this is the difference. A sequence is just a list of numbers. A series would be adding all these numbers up. And with the symbols, the notation would just be A1 plus A2 plus A3. Okay, so that's the difference between a sequence and a series. Now, the general rule for a sequence that's what we mean by A sub n. A sub n represents the nth term of the sequence, meaning if I wanted to find the first term, I could plug in 1 into some formula and it would spit out 5. If I wanted to figure out the third term of a sequence, I can plug in 3 into a formula and it'll spit out 13 as the answer. Okay? So here's what it looks like. Let's say the nth term of a sequence is simply the quantity of 3 minus n squared. And I want you to find the first 4 terms. It's actually as easy as it looks. To find the first term, which again the notation a sub 1 means the first term of the sequence, you just take 1 and plug it into the formula. So you plug in n equals 1, and you're going to do 3 minus 1 squared, which is 2. 2 squared is 4. And we'll repeat that for the second, third, and fourth number. So for a second term, you just plug in 2 for n. 3 minus 2 is 1. 1 squared is 1. To find a third term, you do 3 minus n is now 3. 3 minus 3 is 0, so square it, you get 0. And to find the fourth term, now you do 3 minus 4, because we're plugging in 4 into n. Negative 1 squared is 1. So the first 4 terms, you can just say, here they are. Or if you wanted to write them in order, it'd be 4, 1, 0, 1. These would be the first 4 terms. Okay? That's generally how a rule for a sequence looks like. It'll give you a formula for the nth term, and then you just plug in whatever position in the sequence you want to know about. So if you wanted to know the 8th term, you can plug in 8 in here. 3 minus 8 is negative 5. And then that would give you 25 when you square it. So you can find any term. Whoops, just spilled everything. You can find any term of a sequence as long as you know what the formula is. Okay? Pretty easy stuff. All right. With that being said, let's talk about what a recursive sequence looks like. The key here is that to find the next number in the sequence you need to know the previous terms. So this is a little different than a formula like this. Here, if I wanted to know the 100th term, you simply plug in 100 and you're done. In a recursive sequence, if you need to figure out the 100th term, you'd have a lot of work to do, unless you can find a shortcut around it, because you'd have to know all the 99 terms before in order to figure out the 100th term. And here's what it looks like. Typically what you'll have is one or two, or it doesn't really matter how many, but you'll know some of the terms. So let's say that the first term is 1, the second term is 1, and now you have a rule that says that the nth term, which is what a sub n means, is simply the a sub n minus 2 term plus a sub n minus 1 term added together. Okay, so if you remember what we talked about a few days ago, if you know what n minus 2 is, or where it is in relation to n, and if you know where n minus 1 is in relation to n, this is really easy. Because this notation just means 2 terms before. This just means 1 term before. If I had an n plus 1 or an n plus 2 in here, that would mean the term after and the term after that. Okay, so this is what you would be given. And the problem might say to find the next 4 terms. Okay, so to do that, since I already know what the first and second term is, I need to find my third term. Okay, and if I'm using my formula, this is where n equals 3. Okay, so then when I plug this into the rule, I'm going to do a sub 3, I'm plugging 3 in for n, minus 2 plus a sub 3 minus 1. Okay? And if I want to simplify that, this just means to look at the first term and then the a sub 3 minus 1. That just means to look at the second term. Well, we know what those two terms are. I just plug in 1 and 1 because both of them are 1, add them up. You get 2 for the third term. You can keep this going. So if you want to find the fourth term, again, this is where n equals 4. Plug in 4 into n into the formula, so we have a sub 2 plus a sub 3. A sub 2 was 1. A sub 3 we just figured out, that was 2. Now we get 3. Okay, and you can keep going like this, and you'll get the next two terms if you want. Sometimes another option is to just kind of write them out. 1, 1. My third term was 2. My fourth term was 3. And if you know what's going on here, this is the Fibonacci. Whoops. This is 3. Let me write this over. This is the Fibonacci sequence, one of the most famous sequences of numbers there is. But if you know what this rule means, to find the nth number, you take two numbers before it, one number before it, and add them together. So if I'm looking for the fifth number, I just add the third and fourth number together, you get 5. To get the next number, you add 3 and 5, you get 8. So these would be the next 4. So if you kind of see what the pattern is, you might be able to just kind of figure out the answers. If not, you could always resort to, if I want to figure out the fifth term, I'll show you real quick. You can just take 5, plug it into the formula. So 5 minus 2 becomes 3. 5 minus 1 becomes 4. So now this means look at your third term, look at your fourth term. Third term is 2, fourth term is 3. So we get that the fifth term is 5. So either way you do it, you still get the next term. Okay, so that's kind of what a recursive sequence looks like. All right, now we'll talk a little bit about series and the notation that you're going to be asked to get comfortable with. All right. So there's two types of sums or series. That's really the same thing. There's a finite series, and there's an infinite series. Finite might look something like this. It's clear that there's a pattern here in the sequence of numbers. Every number is just going up by 1. And it's clear that we're stopping at 100. That's what finite means. Finite means that we're stopping at some point and we're going to add everything up. Infinite, the notation, or if you actually wrote it out, would look like this. Same sequence of numbers. Here we're stopping at 100. Here's the same sequence of numbers again, but there's no end. We just keep going and going and going. Okay, so that's the difference between finite and infinite. All right? So just make sure you understand the difference. Now, with that comes sigma notation. The Greek letter sigma is actually what we use to indicate that we're doing a sum or a series, and it looks something like this. Okay, so here's what sigma looks like. On the bottom, you'll have a variable and a starting value. So I'll use k equal to 1. On top, you'll have an end value. So this is to start, plug in 1. And now we keep going. Plug in 2, 3, and so on. This number up here, whatever that is, we stop there. Okay, so if I actually had a formula inside, you can think of this as your rule for the nth term of a sequence. All I do is this. You start with k equal to 1, you plug it in, you get 1. Since we're doing a sum, you add the next term. So now you add in k equals 2. 2 squared is 4. So A1 is 1, A2 is 4, A3, if I plugged in 3 into k, 3 squared is 9, so now I'm going to add 9. And since I don't know where I'm stopping, because I don't actually have a value, but I have a variable, I'll just use this notation that we're going to stop at whatever n is squared. Okay, so that's kind of what the notation looks like. Here's another quick example. So let's go ahead and actually find or evaluate the series defined from I equal to 1. And this is not, you know what, let's make it a j. From j equal 1 to 5. And then the rule is that we're going to do 2j plus 1. And that's it. Okay, so following the same pattern, to find The first number, you just plug in 1 into the formula. So I'll do that kind of right here. 2 times 1 plus 1. That's going to give me 3. So that's the first number. Since this is a sum, we're doing the summation of all these. We're going to add in the next term. The next term is going to be 2 times 2 plus 1, which is 5. Okay, and since I'm not going very far, I'm only going to plug in 1, 2, 3, 4. And since this is 5 on top, that's how I know that I'm stopping at j equals 5. So I'm going to plug in 1, you get 3. You plug in 2, you get 5. You plug in 3, 2 times 3 plus 1, that's 7. I think you can see the pattern here, and you probably don't even have to do the rest of the work. These are just going up by 2. So the next term would be 9. That's what happens when you plug in 4. When you plug in 5, you're going to get 11. And you can confirm. 2 times 5 is 10, add 1 is 11. Okay? And that's how you know that we stopped there. Now you just add these up. So that's 8 plus 7 is 15, plus 9 is 24, plus 11 is 35. So this would be the answer. Okay? Now, in addition to understanding what this notation means and how to write out the series, you should also be able to look at a series and write it in sigma notation. So write a series in sigma notation is one of the other skills you need to know. An example of that would be something like, let's do an easy one. Let's say I have 2 over 3 plus 2 over 4 plus 2 over 5 plus ... plus 2 over 11. Okay? I'll do this in 2 ways. Typically, not that you have to, but typically what you do is pick a letter. So I'll use N. And normally you start at 1, sometimes 0. But really you could start it wherever you wanted to. Okay? And now if you're looking at the list of numbers that you're adding up, you notice, or you try to look for patterns. So if you look at the numerator, you see that the numerator is always 2, so that's going to be 2. But the denominator seems to be changing, so that's where I put my variable n. Okay? And if you look at the numbers here, you see that they're all going up by 1, 3, 4, 5. Next we'd have 6, 7, 8, 9, and then all the way up to 10 and 11. So here's what we can do. If I make this n and then add 2, now this seems to work, because if I plug in 1, you get 3. If I plug in 2 for the second term, 2 plus 2 is 4, so we get our denominator of 4. And now to get 11, you would use 9, and that's where I stop. Okay? We'll do another quick example. Let's say I just have 7 plus 11 plus 15 plus 19 all the way up to 207. Okay? We'll talk more about this kind of series in the next video. But for now, here's a very easy way to find a rule if you notice that the numbers are always going up by the same thing. 7 to 11, 11 to 15, you notice that all these numbers are going up by 4, right? So you can kind of think of that as having a slope of 4. So I'll use 4, let's use k this time. So I'm going to start at k equals 1. And since I'm going up by 4 each time, I'm going to do 4 times k. But now I have to adjust my formula. So when I plug in 1, I end up getting 7. And when I plug in 2, I end up getting 11. So that's not hard to figure out. If you plug in 1, 4 times 1 is 4. You would need 3 more to make 7. Okay, if you plug in 2, hold on. If you plug in 2, you can check that we get 11. 4 times 2 is 8. Add 3, you get 11. So now the only problem is, where do I stop? I know I end up with 207 as my last number. So what we can do is take 207 and set it equal to the formula, which is going to produce 207. You solve for k, and then you figure out where it is that you stop. If you divide by 4, you get k is equal to 51. So this would be the sigma notation of this series up here. You start by plugging in 1 into the formula 4k plus 3. You continue by plugging in 2, 3, 4, etc. up to 51. And then you add up all the numbers. Okay? So now, that's the basics for this section. I will ask you to kind of learn some special sums, so I'll tell you what those are now. These are ones that are frequently seen in applications and show up pretty frequently, especially in calc and things like that. Let's say I have k equals 1 to n k. From k equals 1 to n of k squared. From k equals 1 to n of k cubed. And the last one, from k equals 1 to n of just 1. Okay? If we had more time this year, we would actually prove these formulas using induction, but we don't have that luxury. So I'm just going to kind of go through what they are. I'll write out what the series looks like and then tell you what the shortcut is to calculate it. So if I'm plugging in 1 into this formula, the first term is 1, the second term is 2, second term is 3, etc. And I stop when I get to n and plug it in. So this is what it looks like if you write the series out. The shortcut, instead of actually adding up all the numbers, let's say I had 100 of them, that would take a long time. You could just take the nth number, add 1 to that nth number, divide it by 2, and multiply them together, and you're good to go. Okay? This one, this is the sum of squares pattern, because you're plugging in 1 and squaring it. You're plugging in 2 and squaring it, and then adding everything up. And you keep going until you get to n squared. Okay, the shortcut for this, instead of actually squaring all the numbers from 1 to n and then adding them all together, you could do n times n plus 1 times 2n plus 1 all over 6. Okay, hold on one second. I need to check that real quick. My notebook has something else, but I'm pretty sure it's over 6. Let's see. Yes. It is definitely 6. Okay, I'm not sure why I have something else in my notebook. It's n times n plus 1 times 2n plus 1 all divided by 6. Okay, and the last ones I'll fill in quickly. Sorry for the delay. Which is adding up the cubes from 1 to n. That one is n times n plus 1 all over 2. It's just like the first one, but we're going to square the result. This one here, if you plug 1 into 1, you get 1. If you plug 2 into, you see what I mean? There's no formula, so basically you plug in any number, you get 1. And you do that, n times. So you have n ones here. Well, n ones is just going to equal n. Okay? So this is the list of shortcuts that you need to know and get comfortable with. Here's a quick example illustrating how to use one of these shortcuts. So for example, if I had the sum from k equals 1 to 100 of k, we know that that's 1 plus 2 plus etc. up to 100. That would take a long time to figure out by hand. According to the shortcut, you could just take n, which is 100, and then take n plus 1, which is 101, divided by 2, and there's your answer. You got 50/50. If you want to add all the numbers on your calculator, be my guest. Answer is 50/50. All right, so that's your basic intro to series and sequences. I'll talk to you guys later. Farewell.